Good morning. Um, Hopefully you can see the lesson 22 and 23 slides that I'm presenting. We talked this morning about comparing speeds, comparing rates, and rates are the slope that are represented. And if it is a straight line, to be redundant, then of course that means the rate is constant. And that's why this graph represents Nathan's constant walking speed, because his speed does not change throughout the course of the hours represented in this graph. We also know that Nicole finished a 5-mile walkathon in 1.4 hours. So the question is, who walks faster? So we need to compare the slopes. So going from 0, 0 to 1, 4, I notice it's a 2 and a 4. We've got a change in y over x at 4, and these are miles per hour. And if we take Nicole's 5 miles and divide that by 1.4 hours, the end on that H, on that R there. 5 divided by the 1.4 gives us about 3.57. Okay, so this is approximately 3.6 miles per hour. So Nathan, that's supposed to be a circle. Nathan's name is a circle. Nathan is our fastest walker. There we go. Okay, so another situation here without a graph, but with a table instead. Susan's typing 4 pages of text in 10 minutes. See, the time is always going to be the independent variable. So we're going to go pages per minute. So that's 2/5 of a page per minute, right? We're always going to divide by time, okay? So pages per minute here, this is Ann over on this side, and again it says assuming each are typing at a constant rate, then I've got the pages per minute here. For Ann at 2/3. So that's 0.4 compared to 0.6 repeating. This is the larger value. Changing both decimals, change them with common denominators, or with the common numerators, the larger denominator. 2 of the thirds is more than 2 of something that's only a fifth. So. On today's homework, you got 11 problems. A few of them are like these, where you simply compare the rates given a story, given a table, given a graph. Next part, lesson 23 stuff. We're supposed to sketch this graph 9x plus 3y equals 18 using the intercepts. Okay. So I need a 0, 6, right? Because 0 plus 3 times 6 is 18. And I need a 2, 0, because 2 times 9, 18 plus 0 is 18. So over 2 of 0, and over 0 of 1, 2, 3, 4, 5, 6. Something like so. We'll take a look at this line. Okay, so we sketched the graph using the intercept. Now we're supposed to sketch the graph of the equation y equals -3x plus 6. negative 3x plus 6. So up 1, 2, 3, 4, 5, 6, that's the same point. And going down 1, 2, 3 over 1, that looks like a 1, 2, 3 over that. Oh my gosh, what do we get going here? This appears, if I could draw it more accurately, it appears to be the same line. So let's rewrite this in standard form. Let's add 3x to both sides, and I get 3x plus y equals 6. Okay, so now I'm supposed to identify from part C, A, B, C in the equation. So 3 and 1 and 6. All right, and then the ABC from there is 9 and 3 and 18. And the question, A over A prime, that would be 3 over 9, 1 over 3, 6 over 18. And of course, we're noticing that those are all equal fractions. So if your A over A prime, your B over B prime, your C over C prime, I was supposed to flip those, wasn't I? Sorry. These are not supposed to be flipped. But of course it doesn't matter. 9 over 3, 3 over 1, 18 over 6. All of these equal 3. When you have two equations in standard form, when they're A over A, B over B, and C over C, when those are all equal, then you have the same line. And that's kind of what we're talking about with this today's lesson, right? So the graphs of y equals 2/3 x minus 4, and then 6x minus 9y equals 36, they're the same line. So you're asked to rewrite y equals 2/3 x minus 4 in standard form. So how about negative 2/3 x plus y equals negative 4, right? And now I'm going to take everything and multiply it by 3 to get rid of the denominator 3. That's what I'm going to do. And I get to record this for prosperity. I don't know, prosperity. Okay, so I'm going to put the 3 here. And so then when I do that, then I'm going to get negative 2x plus 3y equals negative 12. So identifying the constants A, B, C from part A. Of course, they are negative 2 and 3 and negative 12. And then noting down 6, negative 9, right? And 36. So A prime over A would be 6 over negative 2, negative 9 over 3, and 36 over negative 12. And although lines aren't going to turn out to be 3 or negative 3, but when they're the same, like you see here, when they're equal, then they're collinear. It's going to be the same line. That's exactly what collinear means. So what do we do here? How do we write equations that are the same? We'll pick a number. 3x minus 2y plus 7. How about 30x and 20y and 70? Right? Because then my A prime over A, B prime over B, C prime over C is going to equal 10. Right? How about negative 3x minus 2y equals negative 7? Pick it. Pick a number. Doesn't matter. Right? If I'm gonna write three equations whose graphs are the same as the x minus 9y equals 3/4, I might get rid of the fraction, right? Multiply everything by 4. So 4 times x minus 36y equals 3, right? Or I might just double everything, right? 2x minus 18y equals 6/4, which would be, 6/4 is 1.5, right? And not only do the A over A prime or B over B prime, C over C prime work with the original equation, but look at this, what I did there in purple, right? 4 divided by 2, negative 36 divided by negative 18, 3 divided by 1.5, those all equal 2. And look what I did in red. 30 over negative 3, 20 over negative 2, 70 over negative 7, those all equal negative 10. Same line. Same line. So same slope, same y-intercept, going to be the same line. Let me see if I get one more slide for you. Okay. So the formative today has 11 questions that are all similar to this. I will meet you all live again on Thursday. See you then.